common sort of troubleshooting situations. One of the first things is no negotiation. What would happen is you would go to the Network Sniffer, and in this case, when I said source of the guy I'm connecting to or destination of the guy I'm connecting to, I'm seeing all this sort of network negotiation traffic. It's all going over. Remember we talked about it goes over port 500. So this was us basically saying, hey, here's who I am. Who are you? You know, do we agree on who I think I am and who I think you are? And they basically said, yep, we agree. And then because we configured for NAT traversal, they switched over to 4500. So if you went, we saw nothing. It's probably a firewall problem on your side, on the VPC, because what that means is nothing's leaving. If we're putting out idents and we're getting nothing back, so if you see this in the log, again, it just repeats, initiating main mode, initiating main mode, initiating main mode. What happens is we're not getting any response back from the other side. So you're hitting, box A at their site, and they've configured it on box B, so there's no response because you're hitting the wrong box. Most often is their network ACLs are not allowing the UDP 500, and in this case UDP 4500 traffic from your VNS Cube's public IP. Also, same sort of thing. It could be that your security groups are not letting the traffic out, so they're not getting a chance to respond, or again, their ACL is wrong. Phase 1 failures. Most often, it'll be pretty obvious if the pre-shared key is wrong. And again, there's two places to see the log, and right, I talked about this. So if I go to IPsec and EBGP, this is the monster log, but this is the log of everything going on inside that VNS cubed, right? And it fills up your browser. It starts at the oldest date and it works its way forward. So it's really a case of the best thing to do would be to download it and then look at it using an offline tool rather than going in the browser. But when you have a connection that's at least put together, you go to one of the tunnels and you say show logs. So in this troubleshooting guide, when I'm saying you see XYZ in the log, you're seeing this information in this section, the above the line section. And you're probably seeing very little going on if there's a problem in the live runtime information. So it's via the show log function here is what I'm talking about. So when the log says probable authentication failure, mismatch of pre-shared secrets, question mark, that is just, it's not always that obvious. There are things where the PSKs mismatch. I think we'll see a different error right after this. But basically what's going to happen is it's going to be a copy paste brought in invisible characters more often than not. We see that a lot, and your partner will swear. They'll say, no, I put it in 10 times. And you have to get them to fess up that they're like copying it out of an HTML based thing or a Word document where you picked up an invisible character. So then the log says for phase 1, it says no proposal chosen. You're mismatching on one or all of the phase 1 parameters, algorithm, hash, and Diffie-Hellman group. There's two things to do there. If you'd gone in and put explicit phase 1 in the params box and it's not working, then what that means is they don't understand how policies are proposed by their device. Most boxes you connect to do not have specific parameters for a connection. What they have is a hierarchy of preferred, what they call policies. And when they make a connection, they just send over their highest policy. So a lot of times what they're using for phase 1 is not visible necessarily in the section of the box that they're configuring, and they don't necessarily know, or they have to go look, or they misread. We take whatever is their highest priority, meaning the thing that they offer first. The best way for us to do it is to match to that. So what you could do is you could remove then the phase 1 equals from the extra params box, and see if VNS cubed will just match, right? Because then we'll sort of try and match to anything they're sending if they're not sending what we thought they were. So again, it could be one or all that they're off. So if we go look at our example host here, edit remote endpoint, and we make our params box a little bigger. If they had said AES 128 SHA-1 DH5, we'll probably mismatch, even though we got the SHA-1 DH5 right. You know, when you first start working with this, you go, well, why doesn't the log just tell me what the other guy's doing? Well, if you'd left the device open to, you know, the firewall open, potentially a hacker could be trying to probe and see what things you accept and what you don't. So the logs don't necessarily, you know, make it clear. What you would like is you'd like the other side to say, hey, dude, I'm saying, you know, AES 128 MD5 DH2. But that is kind of a security risk. So they just tell you we didn't match. So this is another log message where what's most likely going on is that you didn't match on the phase one parameters again. So there's sort of two different log messages here. So the next one is invalid ID information. So what this is a case of where they're wanting, either you need to specify their peer ID in that extra box, or they didn't enter your remote peer ID. So right here, if the remote endpoint is not directly connected to the internet, please enter its private IP address. This is often referred to as IC ID or peer ID, right? So this is the other guy on the other side, what he has. So if you're getting an invalid ID message, it'll tend to be obvious based on the addresses in that error message that either you need to put an entry in this box, or he has a box that he has to put in this entry. And you'll be able to tell that by the addresses that you see in the log. So phase one success, we saw this. So if we go back to our tunnel, we'll see SA established. So when you're dealing with Cisco people, they'll talk about security associations, and they'll often talk about phase one security association, SA, they'll abbreviate, or phase two security associations. So this is what you're aiming for, and that's what we saw here when we go to our tunnel homepage and we do our show log. That's the information that we received. IPsec SA established, and before that we saw Isaac Camp, or phase one SA established, phase two SA established. And again, that information, that's the raw information. You obviously see the same information in a more structured way here. Phase two failure is similar. The no proposal chosen is going to be a number of things. So we see that we had the phase one negotiation was successful, but then we immediately get a delete SA. So this is, we matched, we attempted to do phase two, and the other side says delete your phase one. More often than not, that means that there was a failure getting phase two to agree. So we'll see that. If you see the delete SAs, it usually means that the phase two couldn't agree. If you see the no proposal chosen repeating over and over and over again, but they're not sending the delete SA, they're not deleting the phase one and starting over, and if it's a Cisco ASA, what that means, and then we've seen this, I think, with Barracuda as well, where you're getting your phase one is kept, but your phase two is saying no proposal chosen, no proposal chosen. It still could be a mismatch, but it also, most often, if it's a Cisco ASA, they just have to send any traffic from their side. Cisco has the concept of interesting traffic, quote unquote. And what that means is traffic bound from their network to your side of the tunnel. Cisco won't complete a connection to a non-Cisco device unless there's traffic moving over the tunnel. So you need them to do a ping, anything to sort of light up the tunnel on their side, and then you get your synchronization in place, and then via the rekeys over time, then you're able to keep that connection going. So just in more detail, no proposal chosen though is for phase 2 is broader, right? You might have mismatched on the algorithm and hash. You might have a mismatch on PFS and Diffie-Hellman group. You might have a mismatch on what you're requesting versus what you're offering, so your tunnel specification. You know, again, to go back, if you on your side have 192, 168, 203, 24 is what I'm offering, and what I'm asking for is 172, 31, 103, 024, and what they put on their side was that they were offering their 024, but they were looking for 192, 168, 2030/22, right? So just a wider range. If the policies don't match exactly, you will have a problem. When it comes to the phase 2 no proposal chosen, there's just going to be more work to do because you get effectively the same error message, whether it's a mismatch of your phase 2 algorithm and hash, whether it's a mismatch of the subnets, or it's a Cisco that won't complete the tunnel until you effectively it sends some traffic your way. Sometimes what you will see, you get the phase 1 established, you're not getting any deletes of the phase 1, but you're getting invalid ID information. We tend to see that that's a mismatched subnets. It's implementation dependent based on who we're talking to, what kind of error messages people will send across. And then we showed phase 2 success, and we saw that in our connection. And what you'll see, and we'll talk about this, and it'll be one of the last troubleshooting items, is what you'll see here is NAT-D, this is NAT traversal. You see that NAT traversal is on by there being an IP address here in the log. It's possible for one side to think it's doing NAT traversal and the other side thinking not. And so you'll have a successful connection, but traffic won't pass because one of you is sending on UDP 4500 because you think NAT traversal is on, and the other guy is listening and sending on protocol 50 because he thinks it's off. You get the success message and you're all excited, right? But if you hit refresh in the log or you hit refresh on the tunnel homepage, phase 2 lifetime is 27.054 seconds right now. The last time we refreshed this page, 26.659. So we're counting down nicely. What you'll see is you'll see something like 100 seconds or 300 seconds here, and if you sit watching hitting refresh, it'll count down maybe for 10 or 12 seconds, and then it's back to 300 seconds. So we call that flapping, that the tunnel is flapping. It's connecting and reconnecting and reconnecting. When it's flapping, what is happening is more often than not, your phase 1 or phase 2 lifetime settings mismatch. And it could be either, or phase 1 and phase 2 lifetimes are identical on your connecting partner side, and they've convinced you to say phase 1 lifetime equals 3600S, and they've convinced you to put phase 2 lifetime equals 3600S, and it just causes communication and synchronization problems. But that's almost always the underlying problem. Here's a little more detail. So the tunnel's down, flapping. Sometimes it is because there's packet loss on the intervening route. So that's something that, if you've worked and worked and worked and you've matched up the lifetimes and you've had the conversation 5 different times with your partner, that you need to, that they have to match. Cloud segment they're connecting to is, US East, and they're coming from Singapore, it could be that there's just too much packet loss on the intervening internet route. And then we'd have to try and figure out effectively another way to get to them. I mentioned we got success, but nothing's passing. And so that'll be a case of where, for example, you think that, in your configuration, you've got NAT on, but when you look at the success statement, it says NAT none. Basically, what that means is we offered up NAT, the other side said, nope, I won't do it, and we went ahead and connected, but now we're in this unclear state because we want to use UDP 4500, and they want to use protocol 50. So if you've got a successful connection, everything looks great, but nothing's passing, and it's NAT, you want to make sure that your log says NAT on. If it's native IPsec, you want to make sure that your log says NAT off. Otherwise, you're just sort of sending the right data but out on the wrong network ports. Yeah, and this is just the inverse of each other. The next thing that can happen when you've got success, so we're talking about traffic problems. So one traffic problem is we think we have a tunnel, but we disagree really on NAT, so the traffic's not matching up. The other one is everything looks absolutely fine, but what happens is the overlay clients aren't getting any information. Well, what happens is the overlay clients, we use TLS tunneling technology. We use the OpenVPN tunneling client. And so what happens is the overlay servers only receive routes when they connect. So when you create an IPsec tunnel, or an IPsec tunnel comes up after the overlay server has connected, then what happens is those cloud overlay servers don't have the route. So even though the traffic's reaching them, they don't know what to do with it. So you would see that in the network sniffer, you would see traffic going to the cloud virtual IP address, but you wouldn't see any responses coming back. So what you need to do is restart the tunneling agent on the cloud server. We have a separate piece of software that runs on your cloud servers. That's the VNS3 routing agent. That's a very simple background service for Windows, a very simple background service for Linux boxes. That what it does is when a new route occurs inside the VNS3 network, the tunneling clients are able to pick up that route. Effectively, the routing agent can discover that there's a new route and install it on the local host, and that gets rid of the whole process of stopping and starting the OpenVPN service. So that's something that we would certainly encourage you guys to work with us, have your architects work with us, however you make deployment decisions to get the routing agent on your cloud servers. There is a possibility that there's a traffic problem because somebody tried to do something on the firewall. The VNS3 firewall, sometimes people have no rules in it, sometimes people have lots of rules in it. So it could be a case that somebody was trying to do some sort of natting or address translation because of the customer demand, and you ended up blocking the actual traffic. A couple gotchas. We've connected to just pretty much everything that moves out there. With Cisco ASAs, you will not get the tunnel to complete as a rule unless they're sending some traffic your way. Cisco, by default, has an idle connection timeout, which happens every 30 minutes, that there is no traffic over the tunnel. VNS3 has what we call the ping host. In order to keep that Cisco box from timing out, what you potentially do is you say, well, you know what, let's send and I know that there's a pingable host on their network of that address. I put in a ping host and I say, basically, this is seconds ping interval. Every 30 seconds, send a ping down the tunnel. And so then that keeps the Cisco timeout from kicking in. Ideally, you get the partner to set the Cisco idle connection timeout to 0, which means just keep connections open forever unless they're explicitly closed. Cisco ASA 8.4 At the end of the day, really just your resource is this page. And these videos have just been updated for basic configuration, so give those a look.